Today we're going to do a bunch of things. We're going to do logistics beforehand, and then we'll do what I was hoping to do last time, the introduction to the depression economics unit. But so far we've been doing economic growth, and we've been worrying about capital accumulation and investment requirements and demographic burden and efficiency of labor and so forth. Throw all of that away now. Or rather, don't throw all of that away until you finish your problem set and be ready to bring it back when it's time for the midterm or the final. But now we're going to be moving on to another branch of macroeconomics in which our economic models will have almost nothing at all to do with the model of GDP per worker in economic growth that we've been doing for 2.5 weeks now. We're going to assume for the next, maybe 4 or 5 weeks, that all of the growth economics things are put to one side. That the economy has a trend growth rate, and that trend growth rate is constant, but that what we are really interested in is the extent to which the economy falls below its trend level of economic potential. To what extent is the economy humming like a relatively smooth machine, producing almost all the stuff that it is capable of sustainably producing? And to what extent is the economy falling well short of production with enormous waste in excess and high unemployment? And how do economies get themselves wedged into situations of extraordinary high unemployment like now, and like we saw much worse in the Great Depression? And how do we get out of them? And for that, we need a different framework and a different set of intuitions than for the long-run growth part of the course that we've been talking about up until now. But first, some logistics. Office hours. Today's the first time I'm going to be holding office hours after class on the patio outside the Free Speech Movement Cafe. After class, give me a chance to fill up my coffee cup, and then I'll meet whoever wants to come on the patio afterwards to talk about whatever people want to talk about. Office hours Wednesday right now are shaky. I may get drafted to take part in various economics department recruitment activities as we try to hire additional professors. We being somewhat short of professors right now, which is one reason I'm up here in front of you teaching a course I don't usually teach. And then Friday afternoon, if there's sufficient demand, there's a possibility of holding yet more extra office hours. We'll see. Problem set 3, the Growth Economics Review is due on Thursday, February 10th at the beginning of lecture, right smack here. And there's an error in the problem set. When I relabeled question 3 to question 1 and question 4 to question 2, I forgot to change the references in question 2, what's now question 2, so they refer to question 1 rather than question 3. So for question 2, you're supposed to be assuming that all the parameters are the same as in question 1, except for those that I change. But if you want to assume that all the parameters in question 3 are the same and do the problem that way, I really can't object. And we are working toward an early March 1st midterm, either March 8th or March 10th, depending on how things go. And with that, but for problem set 3, I want you to nail this stuff before we drop it and move on. So let me do one of the problems in problem set 3, only I've changed a couple of the numbers a little bit. So you can't simply take what I'm going to do and copy it down number for number. You've got to figure out what's changed. And the problem asks you to compare growth in South Korea and in the United States and to project them forward into the future using our growth model and using what have become our standard assumptions for growth in an advanced industrial country. That the capital share diminishing returns parameter, alpha, is 0.5 in our model, that the rate of improvement in the efficiency of labor in the United States is 2% per year. Note that the rate of improvement of the efficiency of labor in South Korea has averaged 5% per year since the economic reforms at the start of the 1960s under dictator Park Chung-hee, and assume that both South Korea and the United States today are on their balanced growth paths and are going to stay on them. And the point of this problem is to send you back to our magic canonical economic growth model equation, that output per worker on the left-hand side is equal to the efficiency of labor in an economy over here, times a term that is the steady-state capital intensity of the economy. The capital output ratio, how much the capital stock in the country is worth, divided by the level of real GDP in the economy. And that capital intensity is, we showed, under sort of these oversimplified assumptions, equal to the savings investment effort being made by the economy. The share of production that is being saved and invested in adding to the capital stock, divided by the savings requirements of the economy. And the labor force growth rate, because when the labor force growth rate is higher, that means that more of your investment has to go to equipping extra workers with capital and less is left over to deepen the capital stock at the disposal of any one worker. So an economy with a faster rate of labor force growth is going to be a less capital-intensive economy. The depreciation rate, delta, and as capital wears out or becomes obsolete, you've got to replace that. And the third part of the investment requirements is the labor efficiency growth rate. When labor efficiency is growing fast, you need to invest more, or more of your investment has to go to equipping your workers with the capital they need in order to realize that labor efficiency growth rate. Take this capital intensity term, raise it to this alpha over 1 minus alpha power, which, as I said, in this particular problem is a nice parameter equal to 1 because alpha is 1/2. Multiply that by the efficiency of labor, and you have the level of output per worker in an economy. And if you know how the efficiency of labor behaves over time, and if you know that the economy is on its balanced growth path, so that this gives you its capital intensity, you can figure out how prosperous it's likely to be. So, ladies and gentlemen, part A, to your eye clickers. What is the efficiency of labor in South Korea today in this particular model? We had our problem, South Korea had a GDP per worker level of 40,000. It had a savings rate of 27.5%. It's had a population growth rate of 1%, a depreciation rate on capital of 5%, and a rate of growth of the efficiency of labor of 5%. Those three things, together with your alpha parameter equal to 1/2, should allow you to then figure out what the efficiency of labor is in South Korea today. Let me repeat the numbers you're going to need. You're going to need the GDP per worker level of 40,000. You're going to need the savings share of 27.5. You're going to need the 1, the 5, and then the 5% growth rate for the efficiency of labor. And in order to do that, you're then going to need the magic growth equation. So what do people think? It should be. Yeah. At least the computer thinks it's gotten 77 by now. Yeah. Right. Now they say these are hard to do live and under pressure. They say I only get them right 2/3 of the time. Here we're doing 53% as the right answer. The right answer comes from the fact that our S over n plus g plus delta gives us a capital output ratio of 2.5. so that the level of GDP per worker is then 2.5 times the efficiency of labor, and that gives you an efficiency of labor for South Korea today of $16,000 per year. That's what we're looking for. Now for Part B was the same question for the United States. And if I can back up what we needed for the United States, here I said suppose that the United States has a GDP per worker level of 90,000, population growth rate of 1%, depreciation rate of 5%, savings investment share of 2%, and efficiency of labor growth rate of 2% per year. What then is that going to lead you to conclude should be the rate of, or that should be the level of the efficiency of labor in the United States today? Same big growth theory, master growth theory equation, analogous calculation, but for a different country with different parameters. Okay. You see, and 36. Yep, that's right. That's good. That's excellent. Once again, you have a capital intensity of 2.5 for the United States, only because it's richer. $90,000 per year in output per worker rather than 40,000. That corresponds to an efficiency of labor of $36,000. Note, an interesting fact here is that even though South Korea is saving and investing a significantly greater share of its output than the United States is these days, nevertheless, both economies are about equally capital intensive right now. How can this be so? Well, South Korea has been growing wealthier very rapidly over the past generation. A whole bunch of the capital stock that we have and use in the United States today was made long ago. Look at the Golden Gate Bridge, for example. The Golden Gate Bridge was made in the late 1930s. This means that even though South Korea is investing a large share of current output in its capital stock, a lot of its capital stock still comes from the days when South Korea was a lot poorer than it was now, and so wasn't rich enough to invest very much by our standards. It so happens that these two things balance out. Faster growth on the part of South Korea on the one hand balances out, reduces its capital intensity because a whole bunch of capital was invested with made in the past when South Korea was poor, or poorer than it is now. Higher investment increases its capital intensity. These two things balance out and leave the economies about equally capital intensive. And the United States is significantly richer because we still manage to deploy our labor and have a better trained labor force that is more productive, even though those living in Seoul have much better internet connections than those living in Berkeley, and significantly better cell phone reception as well. What are these differences? Well, McKinsey Global Institute did a very large set of studies, international productivity differences across the world, which I recommend to you if you're interested in going into this in much more detail. But the idea is, or the basic idea is that the United States still has a significant educational edge and also a significant organizational edge. People in the United States spend a lot less time standing around waiting for the cement mixer to show up so that the concrete can be poured than people in South Korea do, even today. Now let's go forward to the part C, where we shift from the magic master growth theory equation to simply doing compound growth. Output per worker in the United States is $90,000 per year right now. What's it going to be in 2100? What's it going to be? Well, it was 90 years from when I first wrote down this problem. And again, approximate, we're looking for things to one or at most two significant figures. What's likely to happen? Assuming nothing bad happens, assuming we don't nuke ourselves or fry ourselves or global warm ourselves into poverty. And see, $500,000 per year, that's the answer, that's the right answer that I'm going to be looking for. Where does that come from? Well, simply take the 90,000 that's current output per worker and multiply it by 1.02 to the 90th power. That gives you $535,000 per worker of current purchasing power GDP come the United States in 2100 if nothing goes wrong and if the pace of modern economic growth continues. At the moment, I don't see any reason why the pace of modern economic growth should not continue absent thermonuclear war, I don't know, a cyber virus plague, or great political upset caused by global warming. You should think about that, because that means that your great-grandchildren come 2100 will be absolutely filthily rich by our standards in ways that we probably cannot fully comprehend. Think back to what the life of your great and great-great-grandparents was back in 1900, compare it to your life today. That seems to be the order of magnitude of difference that we're likely to look at if we don't blow it, if we manage to keep this machine of economic growth rolling. Last question. What will output per worker be in South Korea in 2100? Current level of output per worker at $40,000 per $40,000 per worker per year. Current rate of economic growth, both the efficiency of labor and of GDP per worker at 5% per year. What's this going to produce? Okay, we're hitting the top. Okay, we got a good even spread out here of A, B, and C. I tend to go for C, though I don't think there is a definite right or wrong answer here, and let me tell you why. Well, the first thing you could do is say South Korea is on its steady-state growth path. It's growing at 5% per year in terms of output per worker. It's at $40,000 of output per worker now. Push that forward by 90 years, and you get $3.2 million of current GDP in output per worker for the inhabitants of South Korea in 2100, provided the North Korean government doesn't go absolutely crazy and nuke Seoul at some time in the current lifetime before that situation is resolved somehow. And that situation really needs to be resolved somehow, right? That right now your average citizen of North Korea is 4.5 inches shorter than your average citizen of South Korea. And indeed, why it hasn't been resolved so far is, I think, largely the fault of the People's Republic of China, which has not been playing a terribly helpful role in everyone's attempts to get reform in North Korea, so that we no longer have a government that seems to have most of the defects of high Stalinist communism on the one hand, absolute hereditary monarchy on the other, and kind of theocratic god worship on the third. It really does not seem to be going well. And yet China has, for the past 60 years, thought that it had a security interest in keeping what it has traditionally used to characterize as a United States puppet, South Korea, from having a border on Manchuria. Hopefully, China's attitude will change relatively quickly, and there can be some resolution of the Korean situation. And if there is, and if Korea grows at 5% per year from now till 2100, it will be absolutely, filthily, amazingly rich come 2100. But can South Korea's efficiency of labor continue to grow at 5% per year indefinitely? I would say probably not, right? That South Korea's efficiency of labor is growing rapidly now because there's still a lot of skills to be learned and a lot of technology to be transferred from the North Atlantic industrial core over to South Korea. At some point, that's likely to slow down and stop. And then South Korea's level of the efficiency of labor is likely to grow along with that of the rest of the industrial core of the world economy. Or so I would argue. But even then, South Korea is a high savings country. It's likely to maintain its high savings rate even after its efficiency of labor growth rate slows. That would give it a higher capital labor ratio than the United States. And saying that output for the efficiency of labor in 2100 is the same as the efficiency of labor in the United States would then give you $735,000, which I think is probably the best answer. Yeah? I click the results. Let me see. ABC and 500,000. Oh, and I did this wrong. I actually was supposed to put 735,000 up there. Well, I didn't. So I'd say none of these answers are my preferred ones. Yeah?
Is there information missing on the problem set? Because in the slide, it gives you the value of A and it gives you the value of G.
Yeah. At least I think that's supposed to be in the problem set.
Okay, it's not, they don't give you A or G in the problem set.
All right. Well, A is 1/2, and G is 5% and 2%, respectively. So that's what I want you to do. But some of the numbers are different. That's what I'm hoping you'll take out of this part of the course, and what I'm hoping will stick after the end of the course. That you'll be able to, at cocktail parties, opine intelligently about the relative wealth of different countries in the past and the future by saying, oh, you realize the high demographic burdens of its rapid population growth rate make it likely to be a relatively poor country. Yep? You have a question? No? Okay. All right, so last piece of logistics. Time to start reading about the financial crisis. Time to start reading the auxiliary reading book of this. All the devils are here, so you have something else to talk to in your already overstressed and overcrowded sections. So for sections starting, say, Thursday after class, I want you all to have skimmed and be ready to talk about chapters 1 through 5 of McLeod and Nocera's, McLean and Nocera's All the Devils Are Here on securitization. On how it was that people thought that taking a whole bunch of mortgages, mashing the rights to the money paid out for them into bonds, and then selling the whole thing together as bonds to investors, why people thought this made sense. And then for sections starting a week from Thursday, we're going to be talking about chapters 6 through 8 on policy. For the end of February sections, we're going to be talking about chapters 9 through 15 on the development of the irrational exuberance that led to the big bubble in subprime mortgages in the mid-2000s. Then for the week from sections between March 3rd and March 10th, you get to read about smart guys trying to figure out how to take advantage of the fact that prices of mortgages and of housing look too high, and why their attempts to make money by speculating against an overvalued market doesn't lead to the market correcting itself. That even though there are a lot of people out there who say, wait a minute, this market is too high, there's money to be made by going short, they're unable to put prices back to some normal level. And then that sets up for sections of the last week before spring break, their narrative of the coming of the financial crisis itself. That's going to take up any extra section time you have in discussion between now and spring break. And that stuff about the origins of the financial crisis, I'm really not going to be able to cover in lecture. What I'm going to be talking about during the Depression economics part of this lecture series is the consequences of that financial crisis. Namely, the freezing up of the financing mechanisms by which businesses find themselves able to borrow money to add to their capital stock on reasonable terms, the fall in investment spending resulting from that freezing up, and the consequences of that fall in investment spending for employment and production. So that ends our logistics part of this lecture. A few more brief words on recapitulations on the concepts I hope that you have nailed. Completely nailed, I hope. Yeah, you got this. How much bigger is total world GDP than it was 10,000 years ago? What's the unemployment rate? Yeah, the unemployment rate changed between last Thursday and today, as at 5:30 a.m. Pacific Standard Time, the Bureau of Labor Statistics released the results of its second week of January current population survey of the United States. Of all the households who they found, of all the adults in all the households who they found when they knocked on doors, how many said that they were looking for work and hadn't found a job? Divided by the total number employed plus the total number looking for work. Yes, okay. You got 43% right. The seasonally adjusted unemployment rate reported for January 2011 is 9.0%. Yeah? That's bleak. How's that? All right, that's better. Okay, we'll try to investigate. We'll try to investigate why Microsoft is unable to put the same image, or why Microsoft PowerPoint's unable to put the same image on both screens. All right, thank you. That's appreciated. 9.0. Good number. One interesting thing to note about 9.0, that if you actually look at the survey results, count them all up, and ask what are people actually saying, 9.8% of those whom the Bureau of Labor Statistics classified as being in the labor force in January 2011 were unemployed. But the Bureau of Labor Statistics says the unemployment rate in January is 0.8 percentage points above normal, simply because of the step down from the Christmas selling season. Lots of jobs come to an end, and we expect an extra 0.8 of the labor force to be out of work in January as people who've been working on temporary jobs during the Christmas season start looking for other ones. By contrast, if you look back at December, back then 9.1% of those in the labor force were actually recorded as unemployed, but the Bureau of Labor Statistics reported the seasonally adjusted unemployment rate as 9.4% on the grounds that in December, because of the Christmas rush, the unemployment rate is usually 0.3 of a percentage point less than normal. So what actually happened to the current population survey between December and January was that the fraction of people in the labor force unemployed in the United States rose from 9.1